Hello everyone, myself Qazi Salahuddin, TA of this course called Design of Fixed Wing UAV. Today we will discuss some assignments problem. I hope you got the assignment 1, 2, 3 and 4. So today we will discuss about the assignments problems. Later we have made some more problem. So in next tutorial we will discuss some more problem. So let us start with the assignment 1. In question 1 you have to answer the following question. The unmanned aircraft can be classified based on, the first option was size of the unmanned aircraft, weight of the unmanned aircraft, and third one was the mode of operation, and fourth one is the all of this. So by seeing the question you can directly say that. And second question was the endurance of the aircraft depends upon the. So first option was payload carrying capacity of the unmanned aircraft. So obviously you know that if suppose that payload of the aircraft is increasing, then total weight of the aircraft will increase. So obviously it will depend on parameter. And aerodynamics of the unmanned aircraft. Already you have seen sir thought that ki aerodynamic efficiency L/D ratio. So this one also depends upon the endurance of the unmanned aircraft. And third one was the atmospheric condition. So you know at a lower altitude like sea level density is 1.2256 kg per meter cube. When you go above the sea level the density will decrease. So the endurance will depends upon the speed, and which speed is related to the density. And in the third question, the variation of the properties in the standard atmosphere are calculated based on the assumptions. So here is the assumption is taken G equal to constant, because if you wrote this equation dP equal to minus rho G dH. So this is the hydrostatic equation. Based on then you derive the P2 by P1 ratio, T2 by T1 ratio, and rho 2 by rho 1 ratio. In this equation G assumed to be constant, because if you didn't assume the G equal to constant, means here will be the two variable, G also will be the variable and H also will be the variable. So this is a multi integration, so it will be the complicated one. So that's why we assume the G equal to constant. And we also know that ki, about 0 to 30 kilometer or 32 kilometer, the G variation of G is almost negligible. It is 9.81. So only some 2 or 3% change will be there. So based on that you can also say that G is a constant. So if you take G equal to constant, it will be very easy to derive the pressure ratio, temperature ratio, and density ratio. And in fourth question, the question was the high altitude long endurance unmanned air vehicle is flying at an altitude of 17 km of geopotential altitude. When you say that the geopotential altitude, means you are getting the altitude by keeping the G equal to constant. So you have to find the density at that particular altitude. So the altitude is given 17 km, so you can use the density ratio formula. So you know that ki from 0 to 11 kilometer the variation will be the different, and from 11 to 20 kilometer the variation will be different. So first you have to calculate the density at the 11 kilometer, because suppose that the question, suppose that if the question is find the altitude at the 10 kilometer, then the reference will be the density at the sea level. But here the question is you have to find the density at 17 kilometer. So you cannot take the reference as a sea level. First you have to find the density at the 11 kilometer. You have to take that difference, and then you will go to the density at the 17 kilometer altitude. So let us see, we will solve this problem. So you know, suppose that this is a density at 11 kilometer and density at sea level. So this will be nothing but temperature at the 11 kilometer, temperature at the sea level. Sir already derived these things in previous lecture. G divided by lambda r plus 1. So R is the Gauss constant, 287, lambda is the lapse rate. This depends upon the which layer are you, in which layer you are calculating this density ratio or pressure ratio. So again, this temperature you can find using this relation, T11 equal to T0 minus lambda H. If you want to find the temperature at 11 kilometer, you have to put the altitude 11 kilometer. Lambda is a minus 6.5 and T0 is a sea level temperature 288.16. So if you calculate these things, this will comes around 288.16 minus 6.5 into 11. So I am putting this value directly into this equation. So it will be the easy one-time calculation. So 288.16 minus 6.5 into 11. This will be the temperature at 11 kilometer divided by temperature at sea level 288.16, and this the index will be minus 9.81 into 1000. 1000 we are multiplying because of you have, this is in Kelvin per kilometer and G unit is meter per second squared. So you have to convert all this into SI unit. 6.5 into 287 plus 1. And minus will be there. So these things will comes out 0.75187 and this value will come out to be 4.25864. So this will be the density ratio 11 kilometer by sea level. So sea level density you know is 1.2256 kg per meter cube. So when you solve this, finally you will get the density at 11 kilometer will come out 0.36382 kg per meter cube. So this was the very straightforward question, but you have to keep in mind that you cannot find the density at 17 kilometer using this formula. So first you have calculated this 11 kilometer. Using this you will go to the 17 kilometer. So generally people do the mistake in directly here they can put the T17 and directly you can find the directly they used to find the temperature at 17 kilometer. If you do this, then it will be the wrong. So just only you have to take care one thing. You cannot find the temperature density at directly temperature density or this pressure and density direct at 17 kilometer. First you go to the 11 kilometer, then you will find it. So we have the value rho 11 kilometer. So next we will go to the rho 17 kilometer. So you know that from 11 to 17 or 11 to 20 or 11 to 22, this formula you have to use. In this region the temperature will be the constant, so temperature ratio and pressure ratio will be the same, and this will be G R T11. You have to take the temperature at 11 kilometer and H 17 kilometer and H 11 kilometer. Now you are going from 11 to 17. So you know the value of rho 11 kilometer here you got. This will be 0.36382 and you know this value 9.81, 287 and temperature at 11 kilometer 216.66, and this is 17 minus 11 kilometer, then you have to multiply by 10 power 3 to convert it to meter. So rho 17 you can calculate using this. So this will come out 0.141394 kg per meter cube. This will be the your final answer. So by solving this, you have to take care the two parts. You cannot calculate the density at 17 kilometer directly. Second one, things like the approximate solution. So during the intermediate step, you have to take the at least 5 digits, so that finally you will get the accurate answer. If you take 2 digits, then this will give the error also, and finally if you put that, then the error will come. So your solution will not be the approximate. So at least you take 5 digits. So and in the fifth question, the high altitude long endurance unmanned air vehicle is flying at an altitude of 15 km of geopotential altitude. The true speed in meter per second at that altitude will be nearest to. So here you have here the question was you have to find the true speed. So true speed is basically at what speed the aircraft is flying with respect to the ground. So generally, suppose that you are flying at sea level, so density is different. When you will go to the above the sea level, then density will be the different. So at the same power, you will get more speed. So that is called true speed. So how this density plays the major important role for the true speed, we will see using this example problem. Generally, in true speed, means you can do the mistake like you can put the density at sea level, then that will not be the true speed, that will be the equivalent speed. So we will show you the difference between these two speed using the next problem. And in fifth question, some additional data is also there, which is total pressure sensed by pitot tube, which is 0.1376772 into 10 power 5 Newton per meter square. Suppose that aircraft flying is a particular speed. So in pitot tube, if you bring the flow to zero isentropically means you are not adding any heat and you are not removing the heat from the system. So if you put the flow isentropically zero, you will get one pressure, that is P naught. So if you are not adding any heat and if you are not removing any heat during this process, then you can write this relation P naught equal to P plus half rho V square. So you have P naught and you have to find the speed at 17 kilometer. So you have to find this two value, pressure and density. So this will be the 17 kilometer and this will be the 17 kilometer. So using Stedman formula, I have shown one example to you how to find the density. So density, you know, at the 17 kilometer what will be the density, and density ratio and pressure ratio will be the same, like P17 by P11 equal to rho 17 by rho 11. This will be the same because from 11 to 17 kilometer temperature will be the constant. So if you rho P equal to rho RT, and if you make two equation from this equation, like P17 equal to rho 17 RT 17 and P11 equal to rho 11 RT 11. If you divide these two equations, then this T17 and T11 will be the same. So you will get this. So you know this ratio to from the previous question. You know the P11, you can find the P11. So using this, you can find the static pressure at the 17 kilometer. So from this, if you manipulate this equation, you will get Vt equal to under root 2 P naught minus P at 17 kilometer divided by rho at 17 kilometer. So you have used the Bernoulli equation to find the true speed, but generally people do the mistake, they put the density at sea level. So that will be the equivalent speed. So your answer will be the wrong. So you can see that if the density, if your density will decrease, then speed will increase. Means you are decreasing, if you are going above the sea level, your true speed automatically will increase. So this is the significance of these things. So yes. So these two ratio you know, and if you calculate P17, okay, in this question you have to find the true speed at 15 kilometer. So in last question we have solved the density at 15 kilometer. So you can find the density at 15 kilometer also and pressure at 15 kilometer also using the standard formula. So to find the density at 15 kilometer, again you have to use the density at 11 kilometer, which you got in earlier question. So using this, you can find the value of density at 15 kilometer, which will become 0.212091 kg per meter cube, and P15 will be 0.120322 into 10 power 5 Newton per meter square. So in this equation you can put, see, total pressure is already given 0.137672 minus 0.120322 into 10 power 5 divided by 0.212091. So this will be, some of can get the speed 128, some of get 129. I am getting 128 meter per second. So this depends upon the at what digit you are taking the density and the pressure. So this speed will be the 128 meter per second. So the purpose is to know this, this formula you know, but what is the significance of this where you can do the mistake and all. So you have to just remember this thing. You have to calculate the pressure at 15 kilometer, density at 15 kilometer, then only you can find the true speed at 15 kilometer. So this is the, and if you decrease the density, then the true speed will increase, and this equation is valid for the Mach number when point less than 3 in compressible flow. So this thing you have to keep in mind. And the sixth question was, the temperature ratio as 17 kilometer and 13 kilometer. So you know that from 11 kilometer to approximately 20 kilometer, this is the isothermal layer. So in that the temperature remains constant. So if you take the ratio like 13 kilometer to 17 or 17 to 15 or 15 to 16, the temperature, if the temperature is same, then the ratio will be the 1. So without solving this, you can mark this, you can solve this problem. So the answer will be the 1. And similarly, the density ratio at 20 kilometer and 11 kilometer. So first you have to find the density at 11 kilometer using the standard formula, because you know that from 0 to 11 kilometer the formula will be different to calculate the pressure ratio, temperature ratio and density ratio, and from 11 kilometer to 20 kilometer again the formula will be different. So you have to keep in mind that how this, where we have to use the correct formula. So using the standard formula, you can find the temperature density ratio at 20 kilometer and 11 kilometer. This is question 7. So I am not solving this. You can solve this using, first you have to find the density at 11 kilometer, that you know already. So you can see that the data which you solved for the earlier question, like same data you are using for the next question. So you have to find the density ratio at 11 kilometer to 20 kilometer. That is density ratio at 11 kilometer and 20 kilometer and 11 kilometer. So you know the density is at 11 kilometer is 0.36382 kg per meter cube. This is your one density. You can find the density at 20 kilometer. So you have to find the pressure ratio, means P20 by P11 you have to find. So you can find the P10. Sorry. So you can find the pressure at 20 kilometer, first pressure at 10 kilometer, and then using this you can find the pressure at 20 kilometer and you can divide. So first you have to find the individually P10 and P20. So first we will go to the P10. So P10, for this you have to use the reference sea level, P sea level. So P20, P10 and by P level is T10 divided by T at sea level. This will be the minus G divided by lambda R. So 288.16 minus 6.5, and you have to multiply by the altitude 10 divided by 288.16, and this index will be the 9.81. This is Kelvin per kilometer, then it will go to the 1000 will go to the meter if you convert into the from kilometer to meter. 6.5 with minus sign here will come, and 287. So and at sea level you know 1 bar 1.01325 into 10 power 5 Newton per meter square. You can put this value and you can calculate the P10. So your P10 will be the 0.26418 4189 into 10 power 5 Newton per meter square. So this will be the your P at 10 kilometer. So you got P at 10 kilometer. So our next step is to calculate the pressure at 22 kilometer. Then finally we will divide this two. We will reach our answer. So here you can use some tricks, or you can find the individual at P at 11 kilometer. So you have to find the value of P at 20 kilometer. So P at 20 kilometer you can find using this. P20 by P11 will be the rho 20 by rho 11. I am not using P10 because this two ratio will be the same, na? So you can directly use this data from the previous equation. So what will be the P20 will be? P11 divided by rho 20 by rho 11. So you no need to calculate again, you no need to calculate the P20 individual, like using the formula P20 by P11, P10 equal to minus e to the power minus GRT, H2 minus H1 or H20 minus H10. So using this trick you can find the value of P20 easily using the previous data, because you know the ratio will be the same. So this value you know that ki rho 20 by rho 11 you got from question number 7, and from question number 5 you got the P11 0.22 1566 into 10 power 5, and your density ratio will be 0.25 9092. So your P20 will be the 0.05 8595 into 10 power 5 Newton per meter square. So you have two pressure, P20 and P10 here. So you can divide these two, you will get the answer, and your answer will be P20 by P11. Here you can write P20 by P10 is 0.2279. So you can save some of your time to using this trick. And the 10th question, the 9th question was, at high altitude long endurance unmanned air vehicle is flying at an altitude of 15 km of geopotential altitude. The pressure at that altitude will be nearest to. So you have to find the pressure at 15 km. So you can find the pressure at 11 km, then from 11 km you can go to the 15 km. So at the 11 km, at the 15 km the pressure will be, I am not solving this problem because in many of question we have used the standard this formula, so you have to put just the value and to get the answer. So if you find the pressure at 15 km, it will be come out 0.131839 into 10 power 5 Newton per meter square. So you can see the solution of 5, you will get the idea of how to get the directly the pressure at 15 km. so no need to solve again. And the last question was the value of geometric altitude in kilometer at which the difference between the geopotential altitude and geometric altitude and geopotential altitude is equal to the 1%. So basically in this question, the question was just to give the idea of the difference between the geometric altitude and geopotential altitude. Ki, okay, if you are going above the sea level, then how much it will affect, means is there same for every altitude, means geopotential and geometric, or it will be the different. So the 10th question was the value of geometric altitude in kilometer at which the difference between the geometric altitude and geopotential altitude is equal to the 1% of geopotential altitude. So in this, you know, from the statement you can write that they have said that difference of geometric altitude and geometric altitude is 1%. 1% of geopotential altitude, 1% of geopotential altitude. So this is equation 1. And you know that the relation between geometric altitude and geopotential altitude is H equal to HGR divided by R plus HG. R is the radius of Earth, 6400 kilometer. So if you rearrange these things, then you will get, if you manipulate this equation, equation number 2, you will get Hg by R equal to Hg minus H divided by H, because you have to bring this equation in this form so that you can put this value into directly this and you calculate this. So if you put this value 0.01 and R is 6400, we have taken the correct value of R, which is 6378.14 kilometer. So your geopotential altitude will be Hg equal to 6378.14. Sir already explained about these things, the different this about the significance and physical feel and meaning of this geopotential altitude and geopotential altitude. So this is the one numerical where you can see that the geopotential altitude is coming 63.78. So you can say that ki, okay, which altitude will be the greater, means for each and every altitude Hg will be the greater or H will be the greater. So you can see that ki Hg is, if you put this thing, you can say 0.01 H plus H, 1.01 H, Hg. So if you put Hg value here 63.4, the H value will be the less than that of Hg value. So Hg will be the always greater than of H. At the sea level, it will be the same, but when you go above the sea level, the difference will come. So using this you can say that. So this was about the assignment 1. So we will go to the assignment 2 also. So if you have any doubt regarding this, any steps or things, you can post directly into the forum. we will give the answer. So in assignment 2, first question, an unmanned air vehicle with mass of 700 kg and wing area of 12.47 is flying in cruise at speed of 40 meter per second. The air vehicle trim lift coefficient at mean sea level. So you have to find the CL value. CL trim is nothing but when the forces and moments are balanced, then the aircraft is said to be the trim condition. Means there is no rotation about the CG of the aircraft. So you can call it trim. So basically the given information is mass of the aircraft, which is 700 kg, and wing area is 12.47 meter square, and free stream velocity is 40 meter per second, and you have to find the CL trim. This is at the mean sea level. So you know that okay, if the aircraft is cruising, then the weight of the aircraft is balanced by exactly lift. So using lift equal to weight, which is half rho V square S into CL. So 700, this is a weight, so Newton, so you have to convert into Newton. So 700 into 9.81 equal to 1.2, 1 by 2 into 1.2256 into speed is given 40 meter per second. So 40 square into area is 12.47 and CL trim. So if you solve this, you will get CL trim equal to 0.56144. So in this question, basically the aircraft is flying without any rotation about CG at cruise condition. So just you have to find the value of CL trim. So based on that data, you can see that which equation we have used. See, in cruise condition, if suppose that aircraft is cruising, thrust is balanced by drag and lift is balanced by weight. So which equation you will use? So based on data, you can use that. Okay, we have to use this equation because weight is given, free stream velocity is given, area is given. So all the thing is coming in these equations. So only one parameter you have to find. Then you can use this relation and you can find this. So, and second question is, so in second question, the question was you have to find the value of Cm alpha in per radian at quarter chord point of thin airfoil. And note also you have given that CML is the first derivative of the pitching moment coefficient with respect to the angle of attack. So this is just the introductory part of this, like you can say, stability. And sir already told about that, I think in last lecture, that what is Cm alpha, what is Cm naught, aircraft, what is aircraft stability, and how does Cm alpha and Cm naught plays the important role in longitudinal aircraft stability. So basically here there is the question which is given to solve this, just to introduce the what is Cm alpha. In this question you have to just balance the moment and you will find the answer. So this is little bit tricky. So you have to find the value of at quarter chord point. So you know that you have given the airfoil, and also in this question it is mentioned that the airfoil is thin. Then you can consider as you cannot think about this cambered airfoil or symmetrical airfoil, because in this question you don't need to go about that deep level. You just draw the airfoil and you just try to balance the moment, and at what point you have to balance the moment, then you will find the answer. So in this question you have to find the, suppose that this is the airfoil and one lift force is acting in this direction, and you have to balance the weight, you have to balance the moment. So moment you can write cm force into distance, and if you take the first derivative of that, then cm alpha will become CL alpha x bar minus xac. So this is basically this CL, first this CL is coming from the lift. If you divide lift divided by half rho v square s, this will be the your CL. So first you take the this lift, and what will be the distance between these 2 points, x bar minus xac, this 2 point which I written here. Divide by this coefficient, you will get CL. Take the derivative, you will get CL alpha, and here CM is what? M divided by half rho v square s into c, and c bar you can take here, this is x bar means x by c, and x bar ac means x ac by c. So c will come here, and if you take the derivative, this will become cm alpha. So basically this is the moment, and this is the moment equal to force into distance, and you have asked to find the value of cm alpha at quarter chord, means 1/4 of this chord length. So you know that this is also given quarter, means 0.25 of chord. X bar is already given, so x bar is x by AC, so which is given quarter chord point, so 0.25, and you know that for a location of xac is approximately at quarter chord point of the airfoil, means if you have the chord length, if you divide it by 4, that will give the location of the aerodynamic center. So this will be the also 2.5. So this is 2.5, this is this is 0.25, and this is also 0.25, so this will be the 0. So at the quarter chord point, the cm alpha will be the 0. So later sir will tell you about this key, where the cm alpha will be the 0. At the neutral point the cm alpha will be the 0, and neutral point is the aerodynamic center of the whole aircraft. Sir will explain you about this key, this cm alpha, neutral point, and with the derivation also, then you will get the feel for that. Okay, so basically you are trying to find the cm alpha at aerodynamic center. In the whole aircraft you will find the neutral point, so neutral point will be the aerodynamic center of the whole craft. So at neutral point the cm alpha will be the 0. So you can relate this when sir will explain about you the neutral point, then you can relate this to this, then you will get the feel of, okay, the aerodynamic center of the wing is equivalent to the neutral point of the whole aircraft. So in upcoming lecture sir will explain you very clearly. This is just introduction. And in third question, the maximum distance in percentage of maximum thickness of the airfoil between the mean camber line and chord line. So in a symmetrical airfoil, the mean camber line and chord line will be the coincide. So if you are taking this chord, so mean camber line will be the same as the chord line. So by seeing this question itself, you can say that the maximum distance or distance will be the 0. or in whatever you can with respect to the any percentage or anything you can take. So the straightforward answer will be the 0 because mean Campbell and Colden will coincide each other. And fourth question is which one correct about the aerodynamic center of the airfoil. So basically at the you can see that at aerodynamic center the Cm alpha is 0, means it is independent of angle of attack, and to get the Cm alpha you have to fix the velocity. It means okay, you are getting this Cm at this particular velocity, or you are getting the moment at with fixed velocity. If you change the velocity, the moment will change. So basically in this question the first option was the aerodynamic center and pitching moment coefficient is independent of angle of attack. So see, we have seen that Cm alpha equal to 0 at aerodynamic center. So by seeing this you can say that okay, it is independent of angle of attack. And second and third, fourth option you can eliminate because third option was aerodynamic center varies with the variation of angle of attack, and the location of aerodynamic center depends upon the camber of the airfoil. So by solving this we didn't consider anything, we didn't think about that the cambered and symmetrical things. So this option also you can eliminate, and the location of the center of action depends upon the thickness of the airfoil. Thickness we didn't also consider that okay, we no need to worry about the thickness and all. So the answer was the aerodynamic center. At aerodynamic center the pitching moment coefficient is independent of angle of attack because Cm alpha at aerodynamic center will be the 0. So in the fifth question, the pitching moment coefficient about the leading edge of the airfoil is given by this expression. So Cm is given minus 0.15 plus 0.0315 alpha, where alpha is the angle of attack of airfoil in degrees. The trim of angle of attack of the airfoil in degrees will be. So basically that for the trim, the word trim means that there is no rotation about the CG of the aircraft, means forces and moment are balanced. So moment are balanced means you can put Cm equal to 0. If Cm equal to 0 means there is no rotation about the CG, means it is called trim condition. So if you put Cm equal to 0, you will get the alpha. So basically this equation is given, sir will tell you about the will explain about this significance of this equation, that you can write Cm is Cm naught plus Cm alpha into alpha. So this is basically Cm alpha and this is basically Cm naught. So for Cm naught is negative, unstable, Cm alpha is positive, unstable. Sir will explain these things. Sir already explained these things, the importance of Cm naught and Cm alpha in aircraft stability, aircraft longitudinal stability. So here you can put Cm equal to 0 because it is trim condition. So you will get alpha value will be 4.7619. So in this question you just understand what is trim. If you know what is trim, then you can say that okay, moment is balanced, we have to put Cm equal to 0, you will get alpha. And sixth question you can easily solve by using because we have given the enough hint. So in this question, by increasing or decreasing the free stream velocity, the aerodynamic center will not change. In this case, the difference between the location of aerodynamic center in both cases will be the 0. So whatever you increase the speed, suppose that aircraft is flying 20 meter per second, if you increase the 40 meter per second, the aerodynamic center is a fixed point. It's not dependent upon the speed and all. So in both the cases, the aerodynamic center will be the same. So if you take the difference between both the cases, then obviously it will be the 0. Like CG will vary when you change the weight. CG will not vary will you increase or decrease the speed. Like aerodynamic also is the aerodynamic parameter which is not depend upon the speed and all. So in 7th question, the aspect ratio is given. Aspect ratio is given 10 and wing area is given also 10. So using this aspect ratio equal to B square by S. So B will be under root aspect ratio into S. So aspect ratio is 10, area is 10, this will be the 10 meter. So you have to find the mean aerodynamic chord for the rectangular wing. So in rectangular wing, what will be the taper ratio? CT by CR. So CT and CR will be the same. For rectangular, so lambda will be the 1. So in this case, the root chord, tip chord and mean aerodynamic chord will be the same. So basically you can use this formula aspect ratio which is equal to B by C bar. This is for rectangular wing only and this is for the generalized formula. So people can do the mistake, they can use this formula for all the cases, but this is not true. This is valid for the rectangular wing only. If you put S equal to B into C bar for rectangular wing, this will come out to the B by C bar. So aspect ratio is 10, B is also 10. So from this you can see that 10 by 10 is 1 meter. That only you have to find these things. And for the 8th question, again the lambda is given which is 0.5, which is CT by CR, tip chord by root chord, and CT is given 1 meter. So CR you can find using this. CR will be the 1 divided by this 0.5, which it will be the 2 meter. So first you have to find the, after that you just find the value of mean aerodynamic chord, which will be 2 by 3 CR root chord 1 plus lambda square divided by 1 plus lambda. So this will be the 2 by 3 into 2, 1 plus 0.5 plus 0.5 square 1 plus 0.5. This will be the C bar will be the 1.5555 meter. So in this question you have to find the distance between aerodynamic center of this wing with leading edge or nose. So if you draw, to get the answer of this question you have to draw this figure so that you can feel this. So what is given? This was given 1 meter. And using the data, you found that the root chord will be this chord, root chord. CR is 2 meter. So this thing you know, you draw this and you also find the mean aerodynamic chord somewhere located here, approximately, which is 1.55, this is C bar. So basically you have to find the aerodynamic center of this wing from the nose. You can say this is nose or leading edge, this is nose. So you know that the aerodynamic center for the subsonic wing, subsonic, if your flight is subsonic, then you can approximate the aerodynamic location will be the 0.25 of the mean aerodynamic chord. But this distance will be from here, not from here, and it is asking that you have to find the distance between nose and aerodynamic center, so you have to add this distance also. So to get this distance, what you will do, you can subtract CR minus C bar. So CR minus C bar, if you will subtract CR minus C bar, sometimes I use capital R, small r, it will be the same. So CR minus C bar will be this distance. This distance, you have to add this much distance, because this is the location of aerodynamic center. You can get by dividing C bar by 4. So this distance will be the C by 4. So this distance plus this distance will be your answer. So CR minus C will be this distance, C by 4 will be this distance. So CR minus C will be come out 0.4444 or plus, you know, mean aerodynamic chord 1.555 by 4. So the distance between the nose and aerodynamic center, this is your aerodynamic center, will be you can consider as a x equal to 0.8333. So this will be your answer. This is all about assignment 2. So we will go for the assignment 3 also. In assignment 3, the question was an UAV has a weight 7500 Newton and lift to drag ratio is 13, wing span is 15 meter and mean aerodynamic chord of 1 meter. It is flying at a speed of 35 meter per second at mean sea level. The lift coefficient at cruise will be. So this is very straightforward answer. The weight is given already in Newton, so you no need to calculate, no need to convert. L by D is given 13, B is given 15, C bar is given 1 and V infinity is given 35 meter per second. So at mean sea level, rho will be the 1.2256 and wing you can take rectangular. So using this lift equal to weight, which is half rho v square s into CL. So CL will be 2W divided by rho v square s. So you can put this value 7500 divided by 1.2256 into V is 35 whole square. What will be the area? B into C bar. So B into C bar is 15 into 1. So your CL will be 0.666. This will be the CL. And in second question you have to find the value of CD. So you found out that CL is 0.666 and you given the lift to drag ratio. So lift to drag ratio is given the 13. This is nothing but CL by CD, which is 13. So CD will be CL by 13. So what is CL? 0.66 divided by 13. So CD will comes out 0.512. This will be the CD value. 0.512. 0.0512. This will be the CD value. And the third question, you have to find the value of thrust required. So you know that the aircraft is cruising. So if the aircraft is cruising, so the thrust is balanced by the drag. At that time it will be the thrust required, and lift equal to weight. This is equation 1 and equation 2. If you manipulate using equation 1 and 2, you will get thrust required will be the W divided by L by D. So W is given 7500, L by D is 13. So your answer will be 577.28, which is in Newton. 577. So this will be the your thrust required. Again, you have to in fourth question you have to find the power required. So power required is nothing but thrust required into velocity. So thrust required already you know. Power required you can write thrust required into V infinity. So thrust required you got 577.28. Velocity we already gave you 35 meter per second, which will be the 20.20482, which will be in watt, which will be in kilowatt. So this is your answer of the fourth question. And in fifth question, it's you have to use some trick. If you clear the meaning, if you know the actual meaning of aspect ratio and definition of aspect ratio, then you will get the correct answer of this question. So fifth question was keeping all parameter constant, how the wing span B is related to the induced drag. So suppose that if you fix all the parameter, speed is fixed, weight is fixed, you are flying at a constant altitude, means rho is fixed, your mean aerodynamic chord is not changing at all, then what will be the effect of the induced drag when you increase the span? Like glider has a larger span compared to this trainer type of aircraft like Hansa, Cessna. So this will give the significance of that, this question. So basically in the you can write drag is what? Half rho V square S into CD. If it is induced, you put I. This is induced drag. And from the drag polar, you know that CD is CD naught plus KCL square. So this is parasite drag coefficient and this is the induced drag coefficient. So induced drag coefficient is lift dependent drag and this is parasite drag coefficient, means it will not depend upon the lift. So this will be the induced drag coefficient. So basically this is CDI. So you can put this CDI in equation 1, you will get half rho V square S and CDI will be KCL square. This will be the two things. So half rho V square S CL square and K is what? 1 upon pi into E into aspect ratio. Pi into aspect ratio, half rho V square S CL square 1 upon pi E, aspect ratio is B square by S. This equation you can write this equation. Di is half rho V square S CL square. This will, S will go up, S divided by pi E. So this again we mentioned that the R parameter is constant. Just to bring this equation in span, how the induced drag is related to the span. So this parameter is constant. You can consider this is A only, A by B square. You can consider this A by B square. Here you can do one mistake, that you can aspect ratio, if you put B by C bar, then your answer will be the different. So this aspect ratio B by C bar is valid for the rectangular wing, not the all case. So Di is 1 by B square. So you can see that if you increase the 3 times, means if your weight is increasing 3 times, so basically if you increase the weight of the 3 times, then what will be the CL? So first one, the weight is W. You can say half rho V square S into CL1. So this is lift coefficient when the weight was W. You increase 3 times. 3 times means 3W1. Half rho V square S into CL2. So if you divide these two equations, you will get CL2 by CL1 is 3. Okay? This is the answer for the 6th question. 5th question already I have given the answer. Induced drag is the uniformity proportional to the B square, span of the things. Okay? This is the answer for the 6th question. So in the 6th question, if suppose that your weight was W1 and you increase the weight 3 times, so 3W1 will be the half rho V square into CL2. So CL, if you divide this equation, then CL2 by CL1 will be the 3. Okay? So you know that drag formula is here. Induced drag is half rho V square S into CDI. CDI you can put KCL square. If you divide these two equations in terms of CDI 1, when you put 1, you have to put 1 here. If you CI 2, then CL2. So basically, if you divide this equation, you will get Di 2 Di 1 equal to CL2 by CL1 का square, because CDI is KCL square and all the parameters constant. So if you divide, then you will get CL2 by CL1 whole square. And we have given that weight is increased by 3 times, then you can get the CL2 by CL1 using this. You can put these things into this, you will get 3 square will be the 9. So your induced drag will be the 9 times of the previous one if you increase the weight 3 times. So basically this is the effect of the weight when you not changing any other parameter. So this is the answer of 6th question. The 7th question was, at the STD and state level flight, what will be the flight path angle? You have 3 things here. You have chord line, you have velocity vector, and you have horizon. So you can suppose that this is a horizon and this is your velocity vector. This is your V vector, this is a surface which is parallel to the earth, and this is chord line. So already I told you the angle of attack between chord line and free stream velocity is the angle of attack alpha, and angle between chord line and horizon will be the pitch angle, and angle of attack between the velocity vector and horizon will be the flight path angle. So using this you can say that okay, if you add alpha plus theta you will get theta, alpha plus gamma you will get theta. So theta will be the alpha plus gamma. So if you are cruising at a steady and state level flight, this means your this two line, velocity vector line and horizontal vector line will coincide. This means that your theta will be the angle of attack. So alpha equal to alpha plus gamma, then gamma equal to 0. And for 8th question, the question was a rectangular gun with elliptical lift distribution, span of 10 meter and chord length of 1 meter is constructed with the airfoil having the lift curve slope of 0.1 per degree. What will be the total lift curve slope of the wing? So basically you have to convert these things from 2D to 3D. So we have the information, span is 10 meter, chord length is 1 meter, CL alpha lift curve slope of 2D is 0.1 per degree. You have to find the CL alpha of 3D. So you can use this formula, A equal to A naught 1 plus pi into E into aspect ratio. This means A naught, so pi will be here and A naught will be the here. So A equal to A naught 1 plus A naught divided by pi into E into aspect ratio. A naught is the lift curve slope of the airfoil, A is the lift curve slope of the wing. So you can write CL alpha wing. So with the given information, the wing is given rectangular, so you can find the aspect ratio B by C. Aspect ratio is B by C bar. So 10 by 1 will be the 10. Given that elliptical distribution, so E will be the 1. E will be the 1. And it is given that the lift curve slope of the airfoil is 0.1 per degree. So when you are calculating each and everything, you have to first convert into the radian. So because this pi is given, pi will be the in the radian. So means in each and every formula, if you put the value, means you have to convert into the radian. So CL alpha is airfoil is given 0.11 per degree. Then if you convert into radian, if you multiply by 180 by pi, you will get in per radian. So this will be the comes out 5.7295. 1 plus 5.7295 divided by pi, because here you will put the value of 3.144 something, it is radian, basically 1 into 10, aspect ratio is 10. So you will get CL alpha of the wing is 0.08457 per radian. This is first we can write directly into per radian, then in next step we will convert the per degree. So 4.84574 per radian, multiply by pi by 180, you will get 0.08457 per degree. So you can see that earlier your lift curve slope was 0.1 and now it is decreased. So when you increase the effect, when you increase the aspect ratio, or if you decrease the aspect ratio, then what will be the effect of the lift curve slope, you can see from this answer. That's why sir asked me to design this type of question. So if the aspect ratio is, if you put infinity, then this will become 0 and your lift curve slope of the wing and lift curve slope of the airfoil will be the same. So when the aspect ratio is infinite, means your wing lift curve slope and wing airfoil lift curve slope will be the same. So for infinite aspect ratio, it is called airfoil, and when you have some finite value, then it will be less than that airfoil. You can see this. So in the 9th question, the drag polar is given and you have to find the drag coefficient and maximum L by D ratio. So the drag is CD naught plus KCL square is given. The value of CD naught is 0.016, the value of K is 0.03 CL square. So you have to find the drag coefficient at maximum L by D. So basically you are maximizing the CL. So if you have one equations, then if you want to find the maximum and minimum value, you can easily find. You have to find the CL by CD max, na? This means if you reverse this CD by CL, it will become minimum. So you can divide this equation by CL. So CD by CL equal to CD naught by CL or plus KCL. This is your one function. Let's call this X. So X is your CD by CL. So you want to maximize the CL by CD. This means if you reverse this CD by CL, it will become minimum. So see, you can write capital X equal to CD naught by CL or plus KCL. So if you want to get the value of maximum and minimum value, you have to take the first derivative of this and equate it to 0 with the second derivative. If it is coming negative, means function is maximum, and if it is positive, second derivative is positive, then function is minimum. So based on that you can check. So if you differentiate this with respect to the CL, so dx by dCL will be minus CD naught by CL square plus K. 1 by x differentiation is minus 1 by x square, that's we are written. You have to equate this thing to the 0. Then you will get CL is under root CD naught by K. So if you take the second derivative, this will become the positive. The positive means minimum. For any value of CL and CD, it will be the minimum. So second derivative is minimum, means CD by CL is minimum. So CD by CL is minimum, means L by D is maximum. So this is CL equal to under root CD naught by K. If you put this CL equal to here, you will get CD. CD equal to 2 CD naught. So you will get the relation CL equal to under root CD naught by K and CD equal to 2 CD naught. So the value is given CD naught is 0.016. If you multiply twice, you will get CD. So CD will be 0.032. This will be the your answer. This is the answer of 9th question. And in 10th question you have to find the value of CL. So you know the CD naught under root 0.03, 0.016, and K is 0.03. You will get 0.73. 0296. So that CL will come out to be 0.730296. That will be the answer of your 10th question. And 9th question you have to find the value of CD, which is 2 CD naught, which is 0.032. That is the all about assignment 3rd. So last we will discuss about the assignment 4th. So in assignment 4th, the data is given for the UAV and some additional information is also given. So first we have to go through the information which is given. For an UAV, the wing is rectangular shape. In addition, following data is applicable. The weight of the aircraft is 250 kg and cruise speed is 35 meter per second, and CL alpha is 0.1 per degree. CL alpha of the UAV is 0.11 per degree, and alpha at lift equal to 0 is -2 degrees, C bar is 0.8 and B is 5.5. So in first question you have to calculate the zero lift coefficient at 0 degree trim angle of attack of UAV. So you have to notice in this question that the two lift curve slope is given. One is given for the CL alpha of the wing and second one is given for the CL alpha of the UAV. So you can see that the CL alpha of the UAV is greater than CL alpha of the wing. So how this is coming, sir will explain you when you go for the tail configuration, you will get that okay, lift curve slope of the aircraft is greater than the lift curve slope of the wing alone. Sir will explain about this. So the information is given weight 250 kg, V cruise is 35 meter per second. CL alpha of UAV is given 0.11 per degree, and alpha when lift equal to 0 is -2 degree. Here the lift alpha at lift equal to 0 is same for airfoil, wing and aircraft. So in first question you can, with this given information, first you can find the CL trim. So what will be the CL trim? You can just equate lift equal to weight equal to half rho V square S into CL trim. CL trim will be 2W 2 into 250. It is in kg, you have to convert it into Newton, divided by 1.225 sea level density and velocity square 35 square, and B is 5.5 into C. It will give us area because the wing is given rectangular. So the CL trim will come out 0.425. That will be the CL trim. So in first question you have to find the lift coefficient at 0 degree trim angle of attack of UAV. So you can use these things. Use this relation, CL equal to CL alpha, alpha minus alpha, lift equal to 0. So first question is about the UAV. So here you have to use the lift curve slope of UAV. So 0.11, this is 0 because you have to find at 0 degree trim angle of attack. This is minus 2. So if you multiply this thing, you will get 0.22. CL we have found, this will use in for other question, but this is a straightforward. You can call it as a CL naught because you are finding CL at 0 degree angle of attack. You can find CL naught. Similarly, for second question, you have to find the CL at 0 degree trim angle of attack for wing. If it is asked for wing, then you have to use the lift curve slope of the wing. So use the same equation which we use here. CL alpha, alpha minus alpha, lift equal to 0. Okay. So this thing you have to find, CL naught, because you have to put 0 here, that's why we are putting 0 here. Minus 2, 0.1. Because already we told you that ki, okay, lift curve slope of alpha and lift equal to 0 is same for UAV and wing. So this will come 0.2. You can also say that ki CL naught of the UAV is greater than CL naught of the wing alone. So if you combine this wing and this if you talk about the whole aircraft, then this CL trim is based on the UAV data. This means CL trim is the whole aircraft. This CL trim is not for the wing. This is CL trim is the for whole aircraft. So what will be the at what trim angle of attack UAV is flying actually? You can calculate in third question that we have asked. So in third question, again use the same relation. CL trim equal to CL alpha, alpha minus alpha, lift equal to 0. You can notice that in first two questions we have asked the CL naught by putting alpha equal to 0 for both the case, for wing alone and with complete UAV. But in this question we have asked to find the value of trim angle of attack at this condition. So actually to achieve this speed, what will be the trim angle you have to maintain? So using this data and these things which comes out using this data, you can find the alpha trim. So if you are putting CL trim, you have to put alpha trim here. So you can put CL trim value here. What is the value? 0.7425. And you are talking about whole UAV. So you can put the lift curve slope of the UAV 0.11. Alpha trim you have to find, and you know these things will be the minus 2. So using this, alpha trim will be come out approximately 4.75 degree. And in fourth question we have asked the find the value of CL trim. So this is the answer of the fourth question. And in fifth question, to maintain the same trim lift coefficient obtain in question 4 for UAV at 15 kilometer geopotential altitude, what will be the new cross velocity? So basically, if you go it is asked for the 5 kilometer, right? So this means you are going above from the sea level. This means at that particular altitude, density will be the less than as compared to the sea level density. So to maintain, suppose that your density is decreasing, so you know that ki lift equal to weight half rho v square s into CL. You cannot change s, and this is automatically changing. So weight you cannot change. So somehow you have to balance the same weight. So your speed will be such that the product of v square and CL will be the such that the weight will be the, you can maintain the same weight by changing this v. So v automatically will change. If density will change and you are maintaining the same weight, this means the velocity will change. So how this you can check this using this equation. So if you are not changing anything, means you are not changing CL, you are not changing S, you are not changing W, and you want to maintain the same weight, density will decrease. So if you use the initial velocity 35 meter per second, and if you calculate this thing, this will be not exactly equal to the weight. So if you increase the velocity, this will take care part of the decrease in density. So if you want to maintain the same lift at 5 kilometer, the velocity will increase. So you can see by using this weight we have put here half, density you can use standard atmospheric relation, you can find out, it will be come out 0.7361. V you have to find at 5 kilometer, area is 5.5 into 0.8, and you have to multiply by the CL trim, which comes out 0.7425. So this V at 5 kilometer will be 45.1623 meter per second. You can see approximate 10 meter difference will be there if you fly the UAV at sea level and UAV at 5 kilometer, and if you want to maintain the same weight. And in 6th question, the drag polar is given and you have to find the parasite drag coefficient. So by seeing the equation itself, you can directly say that this will be the parasite drag coefficient. Basically this is CD equal to what is given 0.012 in 6th question I am talking about, 0.03 CL square, right? So this is basically parasite drag coefficient CD naught, and this is K and this is CL square. This is lift dependent, this is parasite drag coefficient. This value, so what will be the CD naught? CD naught will be the 0.012. So during the flight, this will change when you deploy the landing gear flap, and this is a lift dependent things. So if suppose that aircraft is flying and CD naught is gained and suddenly you deployed the landing gear or CD naught, then this value CD naught will change, and sir already explained you about that things. So the 6th question was very straightforward. You can, by seeing that question itself, you can answer this, and you have to find the CL or the same maximum condition. So maximum L by D. So CL you can find using under root CD naught by K, which we have derived earlier. So this will be the 0.012 divided by 0.03. This will be come out 0.6324. This will be your answer. Not answer, you have to find the value of trim angle of attack, I think 7, right? Yes, you have to find the trim angle of attack or angle of attack at maximum range condition. So you know that at maximum range condition L by D will be the maximum. You have to use same formula to get the CL. So you got the CL, and some other information is also given, like alpha lift equal to 0 is also given minus 2.5. Lift curve slope also given, CL alpha is given 0.089 per degree. So alpha lift equal to 0, CL alpha is given, CL you have find out. So you can use this relation. CL is given, CL alpha is given, alpha lift equal to 0 given, you have to find alpha. Then I can use same relation here. So CL is comes 0.6324, right? 0.6324. CL alpha is given 0.089. You have to find this value alpha, and this is also given minus 2.5. So your alpha will be, alpha or alpha trim will be 4.60624 degree. This will be the angle of attack of the aircraft. And yes, and in 8th question the same lift curve slope is given, same alpha at lift equal to 0 is given, and the angle of attack at minimum power condition. In assignment we have missed the word maximum, we have given the maximum power condition, but it is minimum power condition. So like at minimum, like when in the L by D is maximum, means it is the maximum range condition, and for the minimum power condition I will explain about that key how to drive the CL and CD for the minimum power condition. Then you can use, or you can use directly formula. So I am giving you the hint that okay, this CD equal to CD naught, you can write generalized form. This is CD naught and this is K. So sir already about told you that ki CL3 by 2 by CD is a maximum power condition, minimum power condition. So to get, so CL3 by 2 by CD is a minimum power condition, so CD by CL3 by 2 will be the maximum power condition. So you can rearrange these things. You have to put this thing in denominator, sorry, in right hand side you have to manipulate this equation like this. Like we put that L, for L by D we divided these things by CL and we got one ratio here CD by CL, and we assume that is X, and we differentiated with respect to the CL and we got that CD equal to 2 CD naught. And so here you can multiply by CL 3 by 2 actually. If you multiply by CL by 3 by 2, plus KCL 2 divided by CL 3 by 2, differentiate this, equate to 0, you will get CL equal to under root 3 CD naught by K, and CL, if you put this CL into this equation, you will get CD equal to 4 CD naught. So this is the minimum power condition. So in question 7, you have to find the angle of attack, same angle of attack. So these things will change, CL will change, because this comes out using under root CD naught by K, and for this question the CL will be under root 3 CD naught by K. So in this equation itself you can multiply under root 3, you will get the CL, and use the same equations. CL will be the under root 3 CD naught by K, means root 3 into this times. So this will be the 1.0954 equal to 0.089 alpha minus 2.5. So your alpha will be 9.808. You can see that angle of attack at minimum power condition is more than the angle of attack at maximum range condition. So in 9th question, the true aircraft speed is 50 meter per second at minimum drag condition at altitude where the value of atmospheric density is given directly 0.364724. If the weight of the aircraft is 7500 Newton and lift to drag ratio of the aircraft is 13 and wing span of 13 and mean aerodynamic chord of 1 meter, the span efficiency factor E you have to find. So true speed I am writing Vt, 50 meter per second is given, and rho is directly given, no need to calculate, 0.364724 kg per meter cube. W is also given, 7500 Newton. L by D is given, lift to drag ratio 13, C bar is given 1, B is given 13. So the wing is rectangular, so S will be the B into C bar. Use the lift equal to weight and find the value of CL. I will tell you why we have to go first CL, half rho square S into CL. Then this is 7500, 1 by 2, density is given 0.364724, 50 square into 13 into 1, this will be the area and this will be the CL. So CL will come out, lift coefficient will be 1.265. This will be the CL. What will be the CD? CD will be the CL by 13. CL you got na? So you can 1.265 divided by 13. So you will get 0.097431. This is your value of CL and CD using this in given data. So at minimum drag condition, CD will be the 2 CD naught and CL will be the 3 CD naught by K. So you can find the value of CD naught. I will tell you why we are doing these things to find the span efficiency factor. So if you use CL equal to under root 3 CD naught by K and CD equal to 4 CD naught, you can put CD here, use this CD to find CD naught. Then your CD naught will be the 0.0486. So you have to find the span efficiency factor at minimum drag condition. So at minimum drag condition, this 3 will not be there and this 4 will not be there, it will be the 2. So I thought this is minimum power condition, but in question it is minimum drag condition. So minimum drag condition, this is the minimum drag condition, CL equal to under root 3 CD naught by K and CD equal to 2 CD naught. So this will be comes out CD naught equal to this much. Okay, and you know that CD equal to CD naught equal to KCL square. Square these equations, you will get this. Okay, what is K? K is 1 upon pi into aspect ratio, right? And CL is what? You can find the value of CL already now, 1.265. 1.265 square aspect ratio. Aspect ratio, this you can write as a B by C bar, or you can finally, so 13 by 1 will be the 10, 13 by 1 will be the 13. So 13 you can put directly, pi you know, CD naught we have calculated that 0.0486, CL square, CL is given, so you can take E this side and you will get E is 0.8050. So basically you have to think that where the E is coming. So E, if you think that where A is coming, then you can get the K is 1 upon pi into aspect ratio. Where the K is coming in the CL equations. Then you have to find the CL. That's why we have found that CL is 1.265. Then CD is this 0.5, and use this you can get, because in this equation CD naught also is given, is required to solve this. So CD we know, CD naught we know, CD equal to 2 CD naught. So CD also we have to find, then you will get the CD naught, and CL also we have to find to get the K. So if you know the CL, if you know the CD naught, you can square this equation. This equation becomes CD naught equal to KCL square. Put this CL using this, the data which we got here, and CD naught using this, and put the aspect ratio value, you will get the E value. This is all about the assignments. We have made some more problem, some more realistic problem. Sir told me to make this type of problem so that you can feel some more realistic problem. So that we will discuss in the next class, next tutorial. Thank you.